Look at this multi-thousand behemoth moving at 1.6 km/h on its transport track. What you're seeing on your screen is NASA's SLS rocket on its way to Pad 39B at the Kennedy Space Center. Welcome to the next framework in space, the channel where we dissect the present of engineering so we can build the future, often with the help of artificial intelligence. Pay close attention to the images because the week we've had from March 15 to 21, 2026 has been absolutely crazy. To give you an idea of everything we're going to see in the next few minutes, we have the launch of Artemis 2 just around the corner, with Europe making a splash with the Spanish company PLD Space raising a historic round of financing, asteroids that are breaking the known laws of physics. With the JWST, we were spared a major scare, witnessing a breathtaking real-time planetary collision and simultaneously grappling with the audacity of a plan to deploy 88,000 AI-powered satellites into orbit. All of this is happening right now. Let's start with the main course. The SLS rocket is already on the pad at, if all goes well, on April 1, 2026, with a booking window of day 2, astronauts Wiseman, Glover, Koch, and Hansen will climb into that Orion capsule for a 10-day lap around the moon. And I want you to pay attention to a brutal technical detail. NASA has decided to skip the wet dress rehearsal. They replaced the faulty helium valve seal in the assembly building. They put new batteries in the flight termination system, and they said, let's go straight to launch. It's exactly the same philosophy of taking calculated risks that SpaceX uses with Starship. Every time you fill a tank with liquid hydrogen at cryogenic temperatures, you stress the material, so they're not taking any chances. If they launch in the April 1st window, we might have a sunset liftoff and see that crazy bioluminescent jellyfish phenomenon in the sky. I'll leave you with some archive images of what that looks like to whet your appetite. But beyond Artemis 2, what's really blown my mind this week is how the entire lunar program is being restructured from the inside out. The US Congress is pulling the strings and has basically commissioned the development of the EU's second stage. They've been burning money for years on that propellant for future missions, and in the end, they've opted for the practical option. They're going to use the United Launch Alliance's Center 5 stage. It's the same one used by the Vulcan rocket. Check out the move. This stage has twice the fuel as the current one, but integrating it is no child's play. The adapters need to be changed, space needs to be made for the CubeSats, and the launch tower needs to be modified. And here's my opinion, and I want you to think about it. Centaur 5 uses liquid hydrogen. They need to keep that hydrogen hyper-frozen without it all evaporating. If UALA manages to certify that there's no excessive boil-off, NASA will have a much more capable rocket.
Before Carlos tells you more, we ask that you subscribe to the channel. That's the best way to support us in creating more content. Thank you.
And then Jared Isaacman, the NASA administrator, comes out and tells us his master plan. Hold on tight, because he says he wants a lunar mission every month starting in 2027. A monthly cadence. I don't know about you, but my Elon time detector, or in this case, government time, is beeping loudly. I would almost bet on 2030 to see something like that realistically, but the concept is good. He wants to eliminate bureaucracy, prioritize having companies send robots, and build infrastructure to the South Pole before sending humans, and go all in on surface nuclear power and nuclear propulsion to go to Mars. All this while Artemis 3 is being redesigned to be a low Earth orbit test in 2027, where Orion will dock with lunar landers to prove that astronauts can get from one ship to the other without getting killed. And speaking of landers and not getting killed, NASA's Inspector General's office has released a 50-page report that is pure dynamite. They've audited Blue Origin's and the other suppliers' landing systems. It's good. They're on budget. But they're incredibly behind schedule. But what I find a fascinating engineering debate is the beef they have with manual controls. NASA requires astronauts to be able to fly the ship manually in the final meters. They have the trauma, or rather the pride, of Apollo dance, when Neil Armstrong had to take the controls to avoid crashing into West Crater. Companies, on the other hand, say that today's automation is 1,000 times better than the computers of the 1960s, and that putting a human to pilot with a joystick at the last second may add more risk than it removes. In addition, the report points out that the elevator that lowers the astronauts from the high cabin to the lunar surface is a critical failure point. If it breaks, they're left halfway. Now that we've gotten to this point, I'd be very interested to hear your thoughts on this matter of automation. Would you trust your life to a 100% lunar landing algorithm, or would you demand manual control just in case? Let me know your thoughts in the comments, because this is a debate that software engineers and test pilots have every day. Changing the subject, but without going too far from Blue Origin, they have presented a concept together with NASA's JPL that seems to have come out of a movie, the Neo Hunter. It's a planetary defense mission. Picture their blue ring space tug, the one with the giant 140-foot solar panels. The idea is to send it to a dangerous asteroid and use two techniques. First, it hovers nearby and fires a continuous beam of rockets at it. Particle by particle, over months, it nudges the asteroid to deflect it. If that doesn't work because it's in a hurry or the thing is too big, the ship has a plan B. Slamming into it at 6 miles per second like a kinetic impactor is brilliant because it lets you decide your strategy once you're there and see what the asteroid looks like. And speaking of Blue Origin, a quick aside. They've temporarily suspended New Shepard sightseeing flights while they focus on their giant New Glenn rocket. And look how it all connects, because planetary defense has been the big story of the week. The Vera Rubin Observatory in Chile, which has the most brutal digital camera ever created, has started releasing data and has turned physics models upside down. They have detected asteroids that spin on themselves in less than 2 hours, and some in less than 5 minutes. Look, the theory was that most asteroids are rubble piles of debris held together by gravity. If they spin very fast, the centrifugal force should tear them apart. The physical limit was 2.2 hours. But Rubin found them once at almost 1 kilometer across in a 2025 MN45, which makes a complete turn every 2 minutes. This is mind-blowing. What the hell are they made of? Are they solid iron? Do they have some kind of internal cementation that we don't understand? This is a headache for missions like Blue Origin's, because if you try to deflect a giant metal top spinning at that speed with a kinetic impact, who knows where it will bounce off. But fear not, because we also have positive news regarding the space rocks. Do you remember asteroid 2024 YRR4 that had us on tenterhooks because it had a 4% chance of hitting Earth? It got so far away that ground-based telescopes lost track of it. So they took the James Webb Space Telescope, they pointed its infrared sensors at the exact moment its trajectory crossed their field of vision and caught it. They recalculated the orbit and confirmed that in 2032 it will pass within 40,000 kilometers of the moon with zero risk of impact. It is a brutal demonstration of James Webb's technical power. And to top off the asteroid topic, 4 years after NASA's DART mission crashed into the small moon Dimorphos, they were able to measure through stellar occultations that the main asteroid Didymos has also changed its speed by a minuscule 11.7 micron per second. The entire system absorbed the blow. Let's go now to commercial orbit, because Rocket Lab is proving that they are an unstoppable machine. They have launched the 8th synthetic aperture radar satellite for the Japanese company Synspective. It is the 84th flight of their Electron rocket, which remains the undisputed king of small launches. But the big deal is that they have just signed a $190 million contract with the US Department of Defense for 20 flights of their ETS system. They are basically using the Electron rocket to accelerate payloads, to mock and test hypersonic technologies for the military. They have the commercial and military businesses perfectly oiled while they prepare their medium-sized Neutron rocket. For their part, Firefly Aerospace has finally returned to flight after a year of being idle. They launched the Stairway to Sev mission from Vandenberg. It was the last flight of their Alpha rocket in the Block 1 version. From now on, they are introducing the Block 2 version, which is 2 meters taller, has improved avionics, and has fixed the thermal protection problems that caused it to explode last year. The Japanese are not raising their heads with Space 1, the third launch of their small Cairo rocket and third consecutive failure. And the worst thing is that the rocket was going well, the data was nominal, and suddenly the flight termination system, which self-destructs the rocket for safety, activated itself. It already happened to them on the 2 previous flights. Either they have a serious problem in the algorithm, or there is electromagnetic interference that is driving the computer crazy. In any case, the viability of the company hangs by a thread, quite the opposite of China, which is moving at a frightening pace. They have launched 9 more satellites off their Huawei constellation, which is their answer to the Starlink with the Long March 8 rocket. They have launched a military observation satellite. And, pay attention to this, they have launched the Kitsu 11 rocket with 2 very interesting payloads. One is a satellite with integrated artificial intelligence to process images of the Earth directly in orbit, reducing latency when detecting disasters. You can see AI getting into space hardware. The other payload is a prototype designed for refueling satellites in orbit using a robotic arm. And as if that were not enough, the Chinese company Landspace has shown off its new 220-ton thrust liquid oxygen and methane engine with a staged combustion cycle. It is the same technology as the Raptor or the BE-4. They've done over 100 ignition tests. China's not slowing down. In fact, they have confirmed that their mission to return samples from Mars, the Tianwen-3, is still on track for 2028. If they succeed, they will paint the faces of NASA and the ESA, whose Martian sample return program is mired in budget problems. And speaking of the ESA and Europe, we will stop here for a moment because this week has been historic for our continent and specifically for Spain. The company from Elche has closed a Series C financing round of 180 million euros. I repeat, 180 million. Led by none other than Mitsubishi Electric, which in addition to putting up the money, becomes a customer to launch its satellites. In total, PLD Space has already lifted more than 350 million since they started. You know how absurdly difficult it is to get venture capital in Europe to manufacture heavy space hardware? It's nothing short of a miracle. With this money, they have the financial backing to finish the Miura 5 orbital rocket and have it flying by the end of 2026 or early 2027. In addition, Spanish engineer Juan Carlos Cortez has just been appointed chairman of the ESA board. Since of the same so, Spain's influence in the aerospace sector is at an all-time high, and this is something to celebrate. Let's put on our lab coats for a moment because, apart from rockets, the cosmos has given us a hair-raising spectacle. An astronomer from the University of Washington, while reviewing data, detected an anomaly in a star 11,000 light-years away, Gala 20 HK. Visible light was dropping suddenly, but infrared light was going through the roof. Do you know what they were seeing? The exact moment of a hypervelocity collision between 2 protoplanets. We are watching in real time as 2 worlds the size of Mars or Earth have smashed into each other, creating a cloud of debris and molten rock that is expanding right now. Just think of the magnitude of this. It is exactly the same cataclysmic process that created our own moon 4.5 billion years ago when the planet Gaia collided with the early Earth. If we can observe this, it means that the formation of giant moons through massive collisions could be a very common occurrence in the universe, which is vital because our moon is what stabilizes the Earth's axis and ensures that the climate is stable enough for us to be talking about it. And amidst all this scientific wonder, ESA has given us a little bit of a shock. Their mission Test 3, which involves 2 satellites flying in millimeter-thick formation so that one can artificially eclipse the other so that they can study the sun's corona, has had a glitch. The spacecraft carrying the chronograph lost control, failed to enter safe mode, the solar panels stopped pointing at the sun and ran out of battery. They're still in orbit, but they're currently trying to regain contact. Let's hope the European engineers work their magic. I want you to look at low Earth orbit now because the infrastructure we're setting up there is science fiction. The US Federal Communications Commission has just approved an application from a company called Star Cloud to launch a constellation of, 88,000 satellites. It would be the second largest after the million satellites proposed by Starlink. But the crazy thing is not the number, it's the purpose. They're not providing internet. They're orbital data centers to process artificial intelligence. The premise is that on Earth we are running out of power and the capacity to cool the servers on Earth. So they say, let's put them into space. We use kilometer-long solar panels in orbits where the sun always shines and let the vacuum dissipate the heat. They already have a test satellite flying with an NVIDIA H100 processor running Google's Gemini model. It's a brutal idea. But as an engineer, I can tell you that dissipating heat in the vacuum of space is a thermodynamic nightmare because there's no air to carry the heat away by convection. You can only use huge radiators. We'll see how it turns out, but the concept of space computing is already here. At the same time, we've seen an amazing photo of the AAS Space Mobile satellite. They've deployed the largest commercial antenna in history. In the photo, it looks like an Imperial destroyer from Star Wars. It's a metallic swarm designed to provide 4G and 5G coverage directly to your regular phone without any weird antennas, wherever you are. And speaking of low orbit, the International Space Station continues to break records. They just announced that they've already recycled 45,000 kilograms of water. That's sweat, moisture from your breath, and yes, urine turned into drinking water of the highest purity. It may sound gross, but at thousands of dollars per kilo of cargo sent into space, this closed-loop life support system is the only technology that will allow us to survive a 2-year trip to Mars. By the way, it seems that the US Congress wants to extend the life of the ISS until 2032 if the private commercial stations that are gonna replace it, such as Axiom, are delayed. They don't want to leave low orbit empty of human habitation for a single day. The Russians, for their part, have fixed a lunar platform 31 in record time, which broke down in the winter, using spare parts they had stored from platforms that were never built, very much in the style of Roscosmos. Before finishing, there are 2 notes on aeronautics and microgravity that I don't want to let pass. DARPA, the American Defense Crazy Projects Agency, has presented the X-76 built by Bell. It's an experimental vertical takeoff aircraft similar to the OSPR, but with engines in the fuselage and rotors on the wingtips that fold their blades backward when flying fast to eliminate air resistance. They want to exceed 550 km by H. On the other hand, the company Hermes has obtained permission from the FAA to fly its Quarter-Horse 2.1 demonstrator, which uses combined cycle propulsion to try to reach Mach 5, but the real drama in the United States right now is that they have run out of microgravity aircraft. Zero. The Zero-G Industries plane is undergoing maintenance, and it seems that a wing has been damaged. Blue Origin flights are grounded, and Virgin Galactic, if you an American researcher and you need to test something in zero gravity for 20 seconds right now, you have to call Europe and beg to be allowed to board the Novas Airbus A310 in France, Airbus A310 in France. A rather ironic infrastructure crisis for the leading space power. Anyway, if we analyze everything that has happened this week, the conclusion is very clear. The space race has mutated. We're no longer in the 60s. It's not about who plants a flag first. What matters is cadence. What matters is staying put. NASA wants a lunar base. China is preparing its heavy cargo transport system to the moon. Europe is securing its own rockets with ISAR and PLD Space. The question is no longer who gets there first, but who builds the most robust infrastructure to control the resources out there. We're moving from the era of exploration to the era of space logistics, and with that, we'll conclude our review of this incredible week. Have you noticed that the level of engineering currently being handled is out of this world? Never better said. From methane engines to AI processors orbiting over our heads. Now it's your turn. Which news story blew your mind the most? The asteroid that rotates every 2 minutes? The injection of capital into PLD Space? Or the madness of putting data centers into orbit? And most importantly, do you want more videos like this one summarizing space news with all the technical rigor? Leave me a nice comment down below. Subscribe if you haven't already so you don't miss the next analysis, and I'll see you very soon here at the next framework in the space. Greetings to everyone!